Hello everyone, today I'll be covering descriptive statistics. Now descriptive stats describes data deductively without making any inferences with this data. So this could be like finding the mean, finding the standard deviation, all sorts of things. Now before we start, let's take a look at the different types of sampling methods. We have probability sampling and non-probability sampling. I'm going to introduce to you two new terms. The first one is the population. Let's say I have 1,000 students in my cohort, and what I want to collect data about is these 1,000 students in my cohort. Your population is then considered your 1,000 students. Now a sample is just a small portion of this entire population. It's unfeasible to collect data from all 1,000 people, so we use samples to get some information about this population without collecting the entire population's data. Now let's start off with probability sampling. The first method that we're going to look at is the simple random sampling. Let's say again I have this group of 1,000 students. I want to choose a sample size of let's say 50. Then I'll label them 1 to 1,000 and maybe using a random number generator, I can choose my 50 random people. So as you can see over here, the people I've chosen are completely random. That is simple random sampling. The next one is stratified sampling. So for stratified sampling, let me give you an example. Let's say in my 1,000 students, 66% are boys and 33% are girls. So I split the population into two subgroups. What I would then want to do is take 66% of my sample from the boys and 33% of my sample from the girls. And so out of my 50 students that I'm going to choose for my sample, 66% are going to come from boys and 33% are going to be girls. This can be better than simple random sampling because this is more representative of the population. And finally, we have systematic sampling. This is about choosing people in a population very systematically. So let's say every second student over here will be chosen for my sample. Now, we'll be moving on to non-probability sampling. Usually, the non-probability sampling is a bit worse compared to probability sampling. This is because we are choosing people who are convenient for you to choose. Let's say I'm a teacher who wants to collect data about these 1,000 students. What I may do is I may collect data from students whose classes I'm teaching. And as you can tell, this may not be the best representation of the population. Now let's look at the first type, convenience sampling, which is very similar to simple random sampling. This is just simple random sampling, but choosing people who are convenient for you to choose. So let's say I'm a teacher, I'll pick 50 random students from the classes that I'm teaching. That's what you call convenience sampling. The next type is quota sampling, which is very similar to stratified sampling. So let's say again we have 66% boys and 33% girls. As a teacher, how I'm going to do quota sampling is out of the classes that I teach, I'll pick boys for 66% of my sample and 33% of my sample will be girls. Now we're going to move on to measures of central tendency. The first one I'm sure we are all familiar with, the average or the mean. Now if we were to take the mean of these 5 numbers, this would be very easy. We just have 1 plus 3 plus 8 plus 10 plus 25 over 5. To put this into a neat little formula, this is the sum of the frequency times the value x over the sum of all frequencies. In this case, we're taking the sum of each x, 1, 3, 8, 10, and 25, times its frequency. And in this case, the frequency is all 1 because all these numbers only appear one time. And then we have the sum of the frequencies, which is just the total number of numbers, which is 5. Now let's move on to the median. Maybe some of you may be familiar with this. What we're doing with the median is trying to find the middle number. So in the case of an odd number of numbers, let's say 1, 3, 8, 10, 25, we can easily find the middle number, which in this case is 8. However, in the case of an even number of numbers, let's say we have 1, 3, 8, 10, 25, 70, the median will actually be the average of the middle two numbers. So the middle two numbers here are 8 and 10, and the mean of those two numbers is 9. So your median will just be 9. Now the mode is the number that appears the most frequently. So in this case, let's say I have 1, 3, 3, 8, and 10. My mode is just 3. And we can have more than one mode. So let's say I have 1, 3, 3, 8, 8, and 10. We can see that both 3 and 8 appear the most frequently. So our modes will be 3 and 8. Now let's move on to the measures of dispersion. how varied my data set is. The typical few measures of dispersion are the standard deviation, variance, and interquartile range. Now, standard deviation is usually represented by sigma, and variance is just sigma squared, or the standard deviation squared. You can find the formula to find the standard deviation and variance in your formula booklet, but it's not so important. I'll show you how to find out the standard deviation and variance with your GDC. Now the next thing is the interquartile range. Now let's look at this group of numbers again. We know that the median will just be 9, the middle of these two numbers. Now your median can also be known as the 50th percentile because it's kind of like this middle value. And we can also call this Q2. Now for the lower quartile Q1 and the upper quartile Q3, this is the 25th percentile and the 75th percentile. So after we split the numbers in half because of the median, our quartile 1 will just be the middle of these lower set of numbers, which in this case is 3. Your upper quartile Q3 will be the middle of your higher set of numbers, in this case 10, 25, and 70. So your upper quartile Q3 is 25. Now our interquartile range will be Q3 minus Q1, your upper quartile minus your lower quartile. So 25 minus 3 is just 22, and that's your interquartile range. We can represent all of this on a box and whisker diagram. For a box and whisker diagram, we draw our lower quartile to be here, our median to be here, and our upper quartile to be here. Then we draw out these sort of like whisker things, and then write out our minimum and maximum point. So in this case, our minimum can be, let's say, 1, and our maximum can be 70. There's one little note about this minimum and maximum, is that these are not including your outliers. So if you look here, I'll actually draw my outlier here as an X outside the box and whisker diagram. How do we find our outliers? A data is an outlier if it is more than Q3 plus 1.5 times IQR, or less than Q1 minus 1.5 times IQR. IQR is just your interquartile range. So over here, if we find Q3 plus 1.5 times IQR, this is 25 plus 1.5 times 22. That's your interquartile range. And you realize that 70 is just outside of that range. So we can draw it as an outlier on your diagram. Now let's actually explore how to use this outlier condition with a question. Given that the interquartile range is 20 and there are no outliers, find the minimum possible value of U. Now let me write down our outlier condition. A data is an outlier if it is more than Q3 plus 1.5 times the interquartile range. And since we know that there are no outliers and 75 is your maximum value, your 75 has to be within your outlier condition. So it has to be less than Q3 plus 1.5 times the interquartile range. In this case, we know that Q3 is just U. And our interquartile range, as given in the question, is just 20. So we get that U has to be more than or equals to 45. Hence the minimum possible value is just 45. Now let's look at the next question, which we're going to solve with a GDC. Given the following frequency distribution, find the mean and standard deviation of the student's scores. Now this is a very, very typical descriptive stats paper 2 question. I'm going to use the GDC spreadsheets to help us find this. Now if we go into our spreadsheets, what we can do is key in all the data values into this first column. So we'll key in the score into the first column. 3, 4, 6, 7, 8, 9, and 10. That's our score in the first column. We always want to key it into columns and not into rows. And then our frequency for each score, that will be our number of students, will be in the second column. So 2, 6, 8, 3, 5, 4, and 1. Now what we want to do is highlight these two columns. So we'll click the up arrow until it reaches the top and selects the entire column in blue. Then press shift and right arrow to select the second column as well. After we're done with these steps, we come over here to the menu, statistics, stat calculations, and one variable statistics. Now this is the button that we click to get all the descriptive stats. Click OK. Here it tells you that our x, or our data values, is in the A column and our frequency in the B column. We inputted that correctly, so we can just press OK. Now, two important things. X bar over here will be your mean. So your mean is approximately 6.38. Now if you come down and scroll down to sigma x, that is your standard deviation. So your standard deviation is approximately 1.97. And tada, we have solved the question. Here's the summary sheet for descriptive stats. Thank you so much for watching.